Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this set of videos I'm going to talk about the two basic market structures that we are going to encounter, perfect competition and monopoly. Throughout these videos we're going to introduce the concept of profit maximization. The general idea is similar across all the different market structures we are going to look at, but the details are a little different. In this video I'm going to start with perfect competition. The characteristics of a perfectly competitive market are: number one, there are many buyers and sellers, each of which is small relative to the entire market. Two, each firm in the market produces identical or homogeneous products that are indistinguishable from one another. Three, buyers and sellers have perfect information. And number five, there's free entry into and exit from the market in the long run. These characteristics together imply that there is no market power in perfect competition. No individual seller has an ability to raise the price above the market price. There is a single market price that applies to everyone and no ability for any individual seller to charge any other price. This market price is determined by the interaction in the market between the supply and demand. Perfect competition is an economic model, meaning that these assumptions simplify a lot of the math for us, but when we try to apply these to a real-life situation, these are very strong assumptions, resulting in very few real-life markets fitting into perfect competition entirely. Agriculture probably comes the closest. There are many buyers because everyone eats, and there are many sellers in the form of farmers, although in practice this assumption even breaks down as well because there are often large buyers in the form of agricultural processors, as well as large horizontally integrated farms. However, most agricultural commodities are indistinguishable and lack any kind of brand recognition, so identical products is fairly reasonable here. While there are no legal barriers to entry in this market, there can sometimes be significant capital investment required, though this is mitigated somewhat by farmers being able to rent capital as opposed to buying it outright. When we represent a perfectly competitive market graphically, we're going to draw two side-by-side graphs. On the left, I'll label this one with market, and on the right, we have a graph for a firm. There are many firms in this market, all of which are identical, so my one firm graph is a representative for all of the firms in the market. I'll always use the vertical axis for price, and I'm going to use the same scale across the market and the firm graph so that we can draw things horizontally across both graphs when things apply on both sides. On the horizontal axis, I'm going to put a big Q for the market quantity and a small q for an individual firm's quantity. On the market side, the demand curve will look like our normal downward sloping line. All of the individual firms' supply curves, which we will talk about in a minute, will add up to our market supply curve. Will look something like this. This is going to determine the market equilibrium price. We're going to carry that price all the way over to the firm side. Since firms have to just take the market price as given, the demand curve at the firm level is simply a horizontal line at the market price. If a firm attempts to raise the price above this, they're going to sell nothing because everyone else is selling an identical product, and the consumers will simply switch over to buying from the competitors who are still charging the market price. This is what we mean when we say that an individual firm in perfect competition is a price taker. In perfect competition, just like any other market structure, firms are going to maximize profit, which we define as total revenue minus total cost. Total revenue is defined as price times quantity. For an individual firm, price is what it is, P, and quantity is small q. And then we'll subtract the total cost, which we will write as C of Q. That is our firm's cost function. Since price is taken as given, the only decision the firm has to make is how much output should they produce and sell. Because the firm is such a small part of the market, they can sell as much output as they want at the market price without having any impact on that price. To figure out what the profit maximizing quantity is going to be, we are going to take the derivative of the profit function with respect to Q. Since P is taken as given, it's just going to be a constant, so it's going to just be P, And then we have the derivative of the cost function, which is the marginal cost function. We then set that equal to 0 to get our first order condition, or FOC. From there, we just need to solve for Q. Notice that if we were to add marginal cost to both sides of this equation, we would get P equals marginal cost. And this is the profit maximizing condition. In perfect competition, firms maximize profit by producing the quantity such that the marginal cost at that quantity equals the price in the market. This is a good place to also point out that in perfect competition, the revenue function, which I'll call R of Q, equals P times Q. The marginal revenue is the derivative of that, which is just P. So by producing at the point where marginal cost equals price is equivalent to saying that the firms maximize profit where marginal cost equals marginal revenue. Just in perfect competition, marginal revenue is price. As we go on to other market structures, namely monopoly, we will maximize profit where marginal cost equals marginal revenue. And so I want to point out here that what we're doing in perfect competition is no different. It's just that our approach to marginal revenue is very simple because it's simply equal to the price. In other market structures, that is not the case. We can use what we just talked about to determine a firm's short-run supply function. When price changes, it's going to equal marginal cost at a different quantity, and that's going to give us our supply function. To illustrate this, let's consider a perfectly competitive market with lots of different firms, but each of them has an identical cost function of C of Q equals 50 plus 2Q squared. To find the marginal cost, we're going to take the derivative of C of Q. The derivative of 50 is 0, and the derivative of 2Q squared, using the power rule, will be 4Q. To maximize profit, we set this equal to price. If I now divide both sides by 4, I get Q equals P over 4. This is the firm's supply function. Formally, I'm going to write this as Qs of P, since it is now a function of P, equals P over 4. Now that we know what's going on with each individual firm, we are ready to aggregate things up to the entire market to figure out the short-run equilibrium. We will assume that there is some amount of capital that is required to be in the market. Firms that are already in the market have that capital and they're paying a fixed cost on that. And firms who are not in the market do not have that capital and are unable to acquire it in the short run. So the number of firms in the market is fixed in the short run. I will use capital N to denote the number of firms currently in the market. To figure out the market supply function, and I'll use a big Q to denote the entire market's quantity, we're going to add up all of the individual firm supply curves. So I'll add up firm 1's supply plus firm 2's supply, and so on, all the way until firm N's supply function. If every single firm has the exact same cost function, they will have the exact same supply function. This tells us that market supply is N times an individual representative firm supply. Once we know that, we will set the market supply function equal to the market demand function and solve for P to find the equilibrium. Let's do an example. Suppose that the demand function in our market is 200 minus 5 halves P. And we will also suppose that N equals 10. We're going to continue with our firm supply function that we got before, which was Qs of P equals P over 4. This means that our market supply function will be 10 times P over 4, which is 5P over 2. To find the equilibrium price, we're going to set our quantity supplied of 5P over 2 equal to the demand of 200 minus 5P over 2, and then solve for P. I will add 5P over 2 to both sides, which is going to give me 5P equals 200, and then divide both sides by 5, which will give me an equilibrium price of 40. I'm going to use a superscript SR for short run to denote the short run equilibrium values. To figure out the short run equilibrium quantity, I'm going to plug the 40 into either the supply or demand functions. I'll use the supply function, and so that'll give us QSR equals 5 halves times 40, which is going to be 100. To get the quantity that each individual firm produces, we can plug the price of 40 into our firm level supply curve, which is P over 4. So we will get 40 over 4 equals 10. Note also that we have 10 firms. Each firm is producing 10, and that lines up with our total market quantity of 100. 10 times 10 equals 100. Let's go back to the graph and illustrate what we've found so far. Over on the firm side, I'm going to draw the firm level supply curve, which is also the same as the marginal cost curve. We just flipped it around after we set it equal to P. It's the marginal cost and supply. Note that both my marginal cost curve on the firm side and the supply curve on the market side are coming out of the origin of this graph, because if price was 0, quantity supplied was also 0. That does not need to be the case. Be careful when you're doing these, because in some cases the marginal cost will not be 0 at a quantity of 0, and so that's going to lead to a positive intercept for both firm and market supply curves. Our demand curve was QD of P equals 200 minus 5 halves P, which means that our intercept down here was 200 if we plug P equals 0 into our demand function. For the price intercept, we need to know what is the price that would drop quantity all the way down to 0. To do that, we take 200 times 2/5, which is 80. Put that on the graph. The equilibrium price we found was 40. Market equilibrium quantity was 100. And over here, the price of 40 carries on over to the firm side, and we had an individual firm quantity of 10. The last thing to do in the short run is to calculate the profit that each firm is going to make. Profit is total revenue minus total cost. Total revenue is price times quantity, so 40 times the 10 that each firm is going to produce, minus the total cost, which is 50 plus 2Q squared. Q, again, is 10. Here we get 400 minus 50 minus 2 times 100, so 200. That's going to come out to 150. I'll label this as pi SR again for the short run equilibrium. Another way to calculate the profit, and this is convenient for graphing, is to rewrite profit, which is price times quantity minus C of Q, is to factor out a Q. So if I pull a Q out from here, I'm just going to be left with P minus cost divided by quantity, which is going to be average total cost. In our example, average total cost will be our total cost of 50 plus 2Q squared divided by Q, which will be 50 over Q plus 2Q. If I then plug in our short run equilibrium quantity of 10, we get 50 over 10 plus 2 times 10, which is going to come out to 25. I'm then going to plug everything into our formula right here. So profit will be quantity of 10 times an equilibrium price of 40 minus the average total cost of 25. This will be 10 times 15, which is also going to be 150. Either way we calculate this, we'll get the same answer. The reason that we do this is that we can then draw the average total cost curve on the graph and represent profit as a rectangle. Average total cost is always a little bit tricky to graph because it's not a straight line, it is a curve. And you don't need to draw this perfectly, but the thing that you always want to get right is the general shape and also where its lowest point lies, which is the efficient scale. To figure out the efficient scale, we need to find the point where marginal cost crosses average total cost, and then solve for Q. Our marginal cost here is 4Q. We set that equal to 50 over Q plus 2Q, our average total cost function. I'm going to subtract 2Q from both sides. That'll give us 2Q equals 50 over Q. Multiply both sides by q, we get 2q squared equals 50. Divide both sides by 2 to get q squared equals 25. And then take the square root of both sides to get q equals 5. That tells us where the lowest point of the average total cost curve is, which is also where it crosses marginal cost. To see the level that happens at, we can plug this 5 into either of our functions. I'll just use the marginal cost here. So we get 4 times 5 equals 20. Now I'm going to go over to the graph and draw this in. We found just a minute ago that our efficient scale happens at a quantity of 5, so I'll mark that out. We also know that the lowest point of the average total cost curve is going to be right there, and that happens at 20. And so you can see that's about half of where we were at 40. We also know that it's going to get up to 25 at a quantity of 10, which we solved for earlier. So that's going to be somewhere about right there. And that's going to give us just a few points to help us just draw the graph. So it's going to come down like this. It's going to cross over at marginal cost at its lowest point. And then it's going to start coming up. It's going to cross right there, and then just gently come up, something like that. That's going to be our average total cost curve. To see the profit on the graph, we have a box with a base of 10 and a height of 40 minus average total cost, which is 25. And so we can draw this across at 25, which again is where the average total cost curve sits at a quantity of 10. And we're going to get a rectangle that looks like this. This is going to be our short run profit. Recall that in our example, it was 150. As I mentioned before, the number of firms is fixed in the short run because it's impossible to enter or exit the market. However, that is not the case in the long run. In the long run, it's possible to enter the market, and firms are going to do that if they see there is positive profit to be made, which in our example, there is. On the other hand, if firms are making a negative profit, they're going to start leaving the market. This means that there is only one point that can be our long-run equilibrium, where the profit is exactly zero, meaning that no firms have an incentive to either enter or exit the market. If profit equals quantity times price minus average total cost, the only way to make this thing zero is if price is equal to average total cost. And since price is also equal to marginal cost when firms are maximizing profit, the long-run equilibrium price will be at the point where marginal cost equals average total cost. In our example, that happens right here at 20. The minimum point of the average total cost is the long-run price. So to solve for the long-run equilibrium, step 1 is to set marginal cost equal to average total cost like we did before, and find the quantity where they are equal. That is going to be the long-run equilibrium quantity per firm. And so I'm going to put an LR superscript to denote that. The long-run price is going to be the corresponding level of the marginal cost and average total cost. They're equal there, so it doesn't matter which one you use. Once we know the long-run price, we can then plug that into our demand function. Our demand function was 200 minus 5 halves P. And so our long-run equilibrium quantity in the market will be 200 minus 5 halves times 20. So we're going to get 200 minus 50. And so our long-run equilibrium quantity in the market will be 150. The final step to figuring out the long-run equilibrium is to figure out how many firms will be in the market. In our example, we had 10 firms to start with, but firms were making positive profit, meaning new firms are going to enter the market, increasing the total market supply. Had they been making negative profit, firms would exit the market. We had 10 originally. Let's see how many we have now. To solve this, we're going to use the fact that big Q equals N times little q. Plugging this in, we've got 150 as the total market quantity equals N times the little q, which is 5. So that means N in the long run will be 150 over 5, which is 30. There will be 30 firms in the market. To figure out what our new market supply curve will be, remember that QS of P equals N times QS S of P, but it's the little q on the right. And we have 30 times the individual firm supply function, which we solved for a few minutes ago, P over 4. And that will be 15P over 2. Note this is 3 times as much as our original market supply curve, which was 5P over 2. Just to verify we did all of this correctly, let's calculate the profit, and it should come out to 0. Revenue is a price of 20 times an individual firm's quantity of 5 minus the total cost, which is 50 plus 2q squared, so 2 times 5 squared. Revenue will be 100, then we take minus 50 minus 2 times 5 squared. 5 squared is 25, so we get minus 50, and of course that's going to come out to 0, just like we predicted. Let's go back over to the graph to finish this thing off. Let's add all of our new information about the long-run equilibrium to the graph. We know that in the long-run equilibrium, the price is going to be 20, which is the minimum of the ATC. So I'm going to draw this all the way across our market graph. The point where 20 hits our demand curve is going to be our market equilibrium quantity, which we solve for as 150. That's going to move our firm level demand curve down here so that it is tangent with the average total cost curve. It's crossing at that lowest point. Now on the market side, we have a new supply curve because more firms have entered the market. This is going to rotate our supply curve to the right or clockwise until it crosses through our new equilibrium. And that is going to be our new supply curve, which was 15P over 2. Let's summarize perfect competition. In equilibrium, whether it's long run or short run, price equals marginal cost. That means that the marginal value to the buyers and the marginal cost to the firms is equal in equilibrium. If firms were to sell any more than that, then marginal costs would get pushed above what people are willing to pay, and that would not be efficient. If they were to produce any less, then we would be leaving value on the table. This means social welfare is maximized in equilibrium in perfect competition, and we consider, from society's point of view, these markets to be efficient. In the long run, firms make exactly zero profit. That is not to say they are not making money, because in economics, when we talk about zero profit, we are talking about zero economic profit. Firms are making a positive accounting profit, meaning more money is coming in than is going out of the firms. But when they're making zero economic profit, this means that being in the market is just as good as not being in the market. This has been a summary of how to maximize profit and figure out the short run and long run equilibrium in perfect competition. In the next video, we're going to cover monopoly.